If you remember a couple of days ago, I said you're not allowed to have a radical in the denominator of a problem. When that happens, what we have to end up doing is called rationalizing. It says one way to divide radicals is to rationalize the denominator. This means that we write the fraction as a fraction with a real number as the denominator as opposed to a radical. Okay, so for the first one, 1 over radical 3. I need to get rid of that radical 3 in the denominator by rationalizing. And the way you rationalize is you multiply by that radical in the denominator in both the numerator and the denominator. 1 times radical 3 is radical 3. Radical 3 times radical 3 is radical 9. And you know the square root of 9 is just a 3. What I want you to notice, because we are going to see it all year long, if you multiply a radical by itself, you end up getting the piece under the radical only. So radical 3 times radical 3 is 3. If I were to do another one, for an example, radical 5 times radical 5 will be 5. Radical 12 times radical 12 would be 12. So just get used to seeing that so you don't have to show this middle step right here. You can just go from here to here. Our next example, 15 over 5 radical 3. I need to multiply by the radical 3 to get rid of it. Now I could multiply by 5 radical 3 if I chose to do so, that whole denominator instead, but this will be a little bit easier for me. 15 times radical 3 is 15 radical 3. 5 times 1 is 5. Remember that 1 right there. Radical 3 times radical 3, remember a radical times itself is just the piece under the radical. So it's just a 3. So I get 15 radical 3 over 15. 15's cancel, and you're left with just a radical 3 as a final answer there. Now these next two, because it's combined by addition and subtraction, I'm not just going to multiply by radical 5 or radical 2. I'm going to multiply by what's called the conjugate instead. And it's important that you know what that word is, and we'll see it over and over throughout this year. Because sometimes the regents will ask, well, what is the conjugate of 3 plus radical 5? And it'll be multiple choice, and all you have to do is realize that the conjugate is the same thing except change the middle sign. So plus radical 5 becomes minus radical 5. And then we multiply. 1 times 3 minus radical 5 is 3 minus radical 5. And in the denominator, that's a FOIL problem. 3 times 3 is 9. 3 times negative radical 5 is negative 3 radical 5. Radical 5 times positive 3 is positive 3 radical 5. Radical 5 times negative radical 5. A radical times itself is just the piece under the radical. You do have a positive times a negative, so it'll be negative 5. Combine like terms in that denominator. The 3 radical 5's cancel. So you just have 9 minus 5 is 4. So your final answer is 3 minus radical 5 over 4. One more example like that for practice, because those tend to be the more difficult ones. We need to multiply by the conjugate. Well, the conjugate of b minus radical 2 is b plus radical 2. And we will FOIL. A times b is ab, plus a times radical 2 is a radical 2. B times 2 is 2b. 2 times radical 2 is 2 radical 2. And in the denominator, it's FOIL. B times b is b squared. B times radical 2 is b radical 2. B times negative radical 2 is negative b radical 2. Negative radical 2 times radical 2 is negative 2. Notice that the b radical 2's cancel, So you're left with that numerator over b squared minus 2. I'm not going to take the time to rewrite it, but just realize it's that whole numerator divided by b squared minus 2. Next problem says we just need to solve the equation. We've done a couple of these before in previous lessons, so let's do these last two. First thing I'm going to do to try to solve for a is I'm going to subtract the radical 50. Remember from yesterday, or maybe a couple days ago now, in order to subtract these two radicals, you need to have the same radical underneath. So let's break down 98. Breaks down to 49 and 2. 49 breaks down to 7 and 7. So you got a pair of 7s. So it'll be 2a equals 7 radical 2. 50 breaks down to, 25 and 2. 25 breaks down to 5 and 5. So you got a pair of 5s. So it'll be minus 5 radical 2. 7 radical 2 minus 5 radical 2 is 2 radical 2. So we get 2a equals 2 radical 2. Divide by 2. And you end up getting, remember from a few days ago now, the 2's cancel, so you're left with a equals radical 2. Okay, let's do one more here. First thing I'm going to do is get y's on one side, numbers on the other. So I'm going to add the y, and I'm going to subtract the 1. So I'll get y radical 3 plus y equals 3 minus 1 is a 2. Now a lot of you would have a difficult time seeing how you're going to get the y by itself, because you can't combine y radical 3 plus y, because the other y doesn't have the radical 3 with it. But what you do is you take out a GCF. Watch this. The GCF of y radical 3 plus y is y. Times. The first piece, when you take out a y, you're left with a radical 3. When you take a y out of the second piece, you're left with a 1. Now to get the y by itself, what you do, remember it's combined by multiplication, is we divide by this piece. Radical 3 plus 1. When I divide, that's gone. So I'm left with y equals this right-hand side. But look what's wrong with that right-hand side. You can't have a radical in the denominator. So we need to rationalize. And the way we rationalize is by multiplying by the conjugate. And the conjugate of radical 3 plus 1 is radical 3 minus 1. Alright, so now multiplying 2 times radical 3 minus 1 in that numerator would give me 2, need the pencil, 2 radical 3 minus 2. Remember, distribute the 2 into both pieces. And in the denominator, radical 3 times radical 3 is 3. FOIL, so outside, radical 3 times negative 1 is negative radical 3. Inside, 1 times radical 3 is radical 3. Last, 1 times negative 1 is negative 1. You should see that the radical 3's cancel. 3 minus 1 is a 2, so we have 2 radical 3 minus 2 over 2. Finally, I know it's a long problem. Notice these 3 2's. If those pieces have something that can be taken out, we are going to do that. So, you notice the 2 goes into 2, 2, and 2. So reducing that would give me radical 3 minus 1 over 1. Or you can just leave it as radical 3 minus 1. Final answer there. At this point, you can work on the do now problems. There's only 2 of them.